mentioned a number of times the importance of performing good preventative maintenance on engines equipped with diesel retrofits. Would you expand on that?
I'd be happy to. To review a bit, DPF's trapped soot particles extremely well. However, at some point, that trapped soot must be combusted in a controlled way so that the DPF does not plug up. This combustion process is referred to as regeneration, and depending on the DPF design, this can be carried out passively during the engine's normal operation, or it can be actively carried out at discrete times either on board, during engine operation, or off the engine when the engine is inactive. When the particulate is combusted, residual ash is left over, and eventually that ash must be physically cleaned from the DPF.
So what goes into the DPF must sooner or later come out, right?
Well, that's a good way to look at it. The DPF must be able to balance the amount of soot coming in with its ability to combust the soot away. DPFs are designed for individual engine families having known particulate emission levels according to ARB engine certification records. However, if an engine is emitting excessive soot because of an engine maintenance problem, the DPF will not be able to keep up with combusting all that soot, and ultimately will either plug up or the internal substrate may crack due to the very high temperatures of uncontrolled regeneration. DPFs will also plug up if the engine lube oil consumption is excessive.
So what do I need to do to my engines to prevent DPF plugging and cracking?
There are a number of important things, and engine manufacturers and DPF manufacturers may have other engine maintenance practices to recommend as well. The essential maintenance practices include repair bad turbochargers, bad fuel injectors, and any other bad engine components that can cause high smoke and particulate emissions. Replace failed air intake filters. Monitor lube oil consumption closely to ensure compliance with the engine manufacturer's specifications. Possibly monitor engine wear by conducting analysis for metals in the lube oil during oil changes. If lube oil consumption is excessive, repair all bad components, which may include high-pressure oil-driven fuel injectors, valves, piston rings, etc. Monitor coolant consumption and repair any internal engine coolant leaks, as coolant may deposit on the DPF walls.
Now I understand monitoring lube oil and coolant consumption, but we normally don't know if, for example,